The time is right for connected and automated vehicles. We have had a progression over the past 15 years of active safety systems and sensors coming on board. We have great new computational capabilities on board the vehicle as well as off board. And so you partner these together and then you look at some of the gaps that we've had in mobility. Things like the underserved population that maybe hasn't been able to afford a vehicle, the aged, but even more than that, the U.S. has had an uptick in fatalities. It's a real problem, distraction. And with that, connected and automated vehicles has great potential. That aspect is going to lead to safer roads. EcoCar students are going to be a big part of that.
The EcoCar Mobility Challenge, our teams are going to be implementing both connected and automated vehicle technology, or CAV technology. So the teams will be adding on various sensors and connectivity technology to be able to have a vehicle that's not only partially automated, but also highly connected to the world around it.
The CAV portion brings a whole new set of technical skills to this competition. So in addition to the propulsion system integration skill set, teams are also learning about connected vehicle technologies, automated vehicle technologies to integrate into their 2019 Chevrolet Blazer. So it's a really good chance to learn that design, build, test process that you don't necessarily get in the classroom.
An EcoCar student is a student that we at GM say is almost a trained engineer. The skills they learn in this competition really help them on day one when they hire into General Motors.
MathWorks is interested in the CAVs area because the company has been investing a lot in creating simulation tools and deployment tools for engineers to create algorithms faster, such as the automated driving system toolbox and the vehicle dynamics block set and the powertrain block set. Teams participating in the competition get mentorship support from actual math workers who have tons and tons of industry experience.
NXP is going to be supplying V2X radios to the competition. We'll both be supplying radios that will be on board each of the vehicles, as well as supplying radios that they can communicate to, that will be in traffic lights and that will be other places in the infrastructure around the vehicles.
Bosch is providing 4 radar sensors for each of the teams, as well as 4 motor inverter packages to be distributed amongst the teams. The radar sensors, the teams will be able to perform functions like autonomous braking, adaptive cruise control, blind spot detection, those types of functions. But I'm also interested to see what other cool ideas they come up with. When I see these young people come in and they've been working on the technology that we're working on, it's great to see these resumes and to find the right people for my jobs.
Intel's providing 2 main components for the students: a 6 Series Mobileye aftermarket camera, which will give the car eyes to see the road ahead and perceive the world around it, as well as a Intel i7 computer, which will allow it to act like the brain of the vehicle.
Teams are actually building this vehicle to be tailored towards a car-sharing mobility as a service type of application.
Maven is a personal mobility service. We talk about Maven being a smart, seamless, easy-to-use service. There's an enormous amount of engineering and software that goes behind that to make that seamless experience. From my perspective, I hope that we at least got the students to think differently about the challenges that we're having with Maven, that they're going to have to solve for.
So we're really looking to the future of mobility, looking to where things are going, and helping our students engineer a vehicle that's going to meet the transportation needs of the future